Okay, number 12, the last problem here. This is a half-life problem. So make sure you have the half-life formula written down somewhere. What you start with, what you end with, it's the half-life time, how long the experiment is, and H is the actual half-life. Very similar to the double formula, except it would be a 2, and it would be a D for how long it takes to double. You may want to have both those formulas written down on a piece of paper. You can have formulas written down. All right, number 12, it says, half-life of krypton 91 is 10 seconds. Every 10 seconds, half of it's gone. Have a canister contains 3 grams of the radioactive gas. Find a function that models how much will be left after t seconds. Well, the one thing they tell us is the half-life and how much we start with. So we're starting with 3 grams. And it's raised to the t over the half-life, and the half-life was 10 seconds. So starting with 3, we can put a length of time in, we'll see how much we have left. So that's the answer to part A. Part B, switch it over to PERT. Instead of using this formula, they want you to convert it to a PERT formula. And here's how you do it. And you'll probably want to have this formula written down too. The rate, that's R rate, is equal to natural log of a half divided by what the half-life is. So we're going to convert from using half-life to using the PERT formula. We need to know R when you're using PERT. So that's going to be ln of a half over the half-life of 10 seconds. And you should get negative 0.0693. That's a 0.0693. Why is it negative? Because its half-life is getting smaller. Anytime things are going down, you have a negative if it's PERT. So now we're going to switch to PERT. A equals P. P is still 3 grams. Instead of half, we're going to put E raised to the 693 T. We don't know what T is. That's your formula. That's part B. Part C. Let me find it again. Here we are. How much is left after 1 minute? So we're starting with 3. They're decreasing at 0.0693%. But we know the time is 60 seconds. This was 10 seconds. They said 1 minute, so you got to change it to 60 seconds. Do that on your calculator. Negative 0.0693 times 60. And I got 0.047 grams. Went from 3 grams down to less than half a gram. All right, let me do one more problem here that's not in the book. This is going to be extra, at no charge. How long from 3 grams to 0.002 grams? How long will it take? So we're going to end up with 0.0023 equals, we're starting with 3. Now you can either use the half-life or PERT. I think I'll use half-life. So this would be a half of t over 10. Now if you use PERT, you would put an e here with negative 0.093 times t. Do this on divide first, 0.00. Okay, it's 0.002. I don't know why I wrote it wrong here. 0.002 equals 3. So we divide those two. Haven't worked this one yet, I just made it up. So we're dividing 0.002 divided by 3. And you get 1 over 1500 equals 1/2 raised to the t over 10. So we got to go to log. That's going to be log base 1/2 of 1 over 1500 equals t over 10. Do this and then multiply it by 10. So I'm going to hit log, put a half in the small box. It's easier to put a 0.5. And 1 divided by 1500 in the big box. Hit equals. I got 10.55. I'm going to divide it by 10. Wait a minute. Let's multiply by 10. I got time is 100.5 seconds and a half. I could have worked it using PERT, and the answer would be almost exactly. It might be by 0.6, a little bit off. Okay, that's it.